Hey guys, I just wanted to make a brief video about a new paradigm I've been interested in for philosophy of infinity that I just made called N-finitism. It's very similar in motivation to constructivism, but we're going to um, show useful differences as well. I believe it's the heart of what constructivism was intended to be, but that it's both stricter, more rigorous, and broader and more accepting. So basically, infinitism, and I'll get in a second to why I call it this, but it's a way of mediating discussions. It's a framework for how do we know if we have a good mathematics of the infinite that admits that there's useful reasons people want to be finitists, but that it's possible that many of the nice properties of finite objects are extendable. So basically, it agrees with finitists that there needs to be a universal computational background for defining mathematical objects. In other words, there needs to be some procedure that could actually make them in a number of steps. And it's super easy to formalize this by saying, for an object of a given cardinality to exist, we should need this object to be producible by the n variant of a Turing machine. So it gives a universal way of defining what objects are actually constructible. It's very intuitive. It could be interesting in discussions over the axiom of choice, because the axiom of choice, it allows uncountable procedures to produce Aleph infinite sets if one wants to, but I'm not sure it actually constructs anything that an N-Aleph Turing machine would not be able to construct. If it does, though, that's probably a pretty good argument against it, because it's making Aleph infinite objects that couldn't be made in any Aleph infinite number of steps. It's so anyway, why is this advantageous over constructivism? Well, constructivism, it just has no universal definition of what it means for something to be constructive. Even if it did, it would not prove that the object would actually be made. There's lots of human error involved. This formalizes it, but it's also a lot broader. And another way that it avoids the anthropocentrism of constructivism is constructivists want to say the only kind of, even though they're trying to say the only kind of infinite objects that could exist are those that can be made, they actually end up saying the only kind of infinite objects that could exist are those that could be made by a human mathematician using a finite number of repetitions of a given axiom. And once we're going to believe in any kind of infinity, there's no reason to believe that this would be a good criterion. Of course, we know consistent rules don't break down regardless of how much they're applied. So it's just very limiting to be able to think about only the finitary results of our systems. But the most important thing about this is constructivism involves normally a commitment to what kind of mathematical objects already exist. This is just a framework for mediating discussion. And indeed, even if our current mathematics of infinity falls by its standards, it doesn't say we could not have a mathematics of infinity that would finally be able to treat infinite objects as well-defined entities. It gives us a framework for measuring. In the next video, I'm actually going to apply infinitism and get some really interesting and new results about how our mathematics of infinity actually measures up by its standards. And they're going to be, very unlike anything you've heard before. So